This video is on the objective. Use the sum and difference formula for cosine. This is number 2, second video on a question related to this objective that I'm working on in your Newton Alta homework. So I'm not going to go into as much explanation as I did in the first video. I'm just going to go through and work it how I would say that you should work the problem as well. Alright, so here's the question. See, we're given information about an angle called A, we're given information about an angle called B, and then we're asked to find, the cosine of A minus B. If you were to take angle A and angle B and subtract them, what would be the cosine of that new angle? And give your answer as a fraction. Right, so as I say almost every time, if you want to see more stuff on this, click on more instruction. Look at their videos, their examples, their notes. Hopefully those help you out. All right. So here, I'm going to go through one angle at a time. I'm going to, take the information I have about angle A and draw a picture. Take the information I have about angle B and draw a picture. And then use those two pictures to help me find the cosine of the difference of those two angles, if I were to subtract them. All right. So I'll start with angle A. Now we are told that the sine of angle A is 3/5, positive 3/5. And angle A ends in quadrant 1. So I'll draw a quick picture of angle A. Now, again, you start from the positive x-axis as your initial side. Now, quadrant 1 is just the upper right corner, so there's an angle that ends, I'll call that A, and there's an angle that ends in quadrant 1. And pick a point on the terminal side. It's got an x-coordinate and a y-coordinate. I'll find those and drop a perpendicular segment to the x-axis, creating a nice right triangle. And since angle A that I've drawn here is already acute, and it's already a nice acute angle, I don't need to put in the reference angle like I normally do. And then I'll just set it up so that the sine of this angle is 3/5. Right now, remember, sine is opposite, so over hypotenuse. So I'll say 3 is the length of the opposite side. So the y coordinate of this point up here is 3. And the hypotenuse for the denominator, right? And that's the distance to the origin, and that's what I called r, right? R equals 5, and r is always positive. So positive 5 there. And all we're missing is the x coordinate. Now I'm hoping you could use it, but that I call this x. X squared plus 3 squared equals 5 squared. You'll see that x has to be positive 4. I'm not going to go through all that. This is a 3, 4, 5 right triangle. And it would have to be positive, right, because you're in the first quadrant and x coordinates are positive. So this point here I picked on the terminal side has an x coordinate of 4, a y coordinate of 3, and the distance to the origin is 5. Now I'll do the same thing for angle B. That other angle they gave me information about. Now they told me that for angle B, the cosine of angle B is negative 7/25, and angle B, when drawn in standard position, ends in quadrant 3. All right, so again, standard position, drawing an angle that ends in quadrant 3. Now quadrant 3 is down here in the lower left corner. There's an angle. All right, there's an angle that ends in quadrant 3. I pick a point on the terminal side here. It's got some x coordinate, some y coordinate that I don't know yet. Draw a perpendicular segment to the x-axis, and then there's the reference angle, right, formed by the terminal side and the x-axis. That's an acute angle in this right triangle. Now, if the cosine of B is negative 7/25, I would like the cosine of this acute reference angle to then be positive 7/25. And I'll set up the side lengths, right, so that happens. Now remember, cosine's adjacent over hypotenuse, so the side adjacent to the reference angle should have a length of 7. And since that's left of center, I'll call it negative 7, and that gives me the x coordinate of this point down here. And then the hypotenuse is 25, so r equals 25. That's the distance to the origin, the hypotenuse length. The only thing missing is this y-coordinate. All right, now again, you can set up the Pythagorean theorem, and you'll see that this has a length of 24. And I'm going to call it negative 24 because I'm in quadrant 3, right? And y-coordinates and x-coordinates should both be negative. All right, so again, 7 squared plus 24 squared equals 25 squared. You can double check that. All right, so now I have everything I need about angle B. So now we're putting these together in some way. They're going to subtract them. Now I'm looking at angle A minus B. Now I don't know how big angle A is supposed to be. I don't know how big angle B is supposed to be. So I don't know how big angle A minus B is. Right? So I don't know what quadrant it ends in. And we're not asked that. We're not asked about what quadrant it's in. We're asked to find the cosine of this new angle. If I were to take the angle BA that I showed you and subtract the angle B that I showed you, what would be the cosine of this new angle called A minus B? All right, so this will involve the difference formula for cosine, right? The cosine of a difference, and hopefully this is, I brought this up in the first video on this. Remember, the cosine of the difference of two angles is, the cosine of the first angle times the cosine of the second angle, right? So cosine A times cosine B, and then the cosine of a difference is a sum. Right? Then you got plus, and then the product of the sines. The sine of the first angle times the sine of the second angle. All right, and then I'm just going to fill in these four values. What's the cosine of A, cosine of B, sine A, sine B, and then we'll simplify. We'll add those products together. All right, so the cosine of A. So that's about angle A. I go back to my picture for angle A. Now, I'm told the sine of angle A is 3/5. Well, from my picture, hopefully it's obvious that the cosine of angle A is 4/5, right? So remember x over r, adjacent over hypotenuse of my right triangle here, it's 4/5. So the cosine of angle A is 4/5 times, the cosine of angle B. So I go to my picture for angle B. Now they already told me what the cosine of angle B is. It's negative 7/25. All right, then we got plus. Now I'm looking at the sine of angle A. So back to my angle A picture. Now they already told me what the sine of angle A was. It's positive 3/5 times the sine of angle B, which now I'm looking at my angle B picture. Now I know the cosine, but again, very easy. I could look at my picture, the sine of this angle. Remember, that's the y-coordinate divided by the distance to the origin, negative 24/25. And there's your sine of angle B, negative 24/25. All right. This first product, the denominators would be 125, right? 5 times 25. The numerators, 4 times negative 7, is negative 28. Plus, these have the same denominator, so 5 times, it's 5 times 25, 125 again. So we got a common denominator. We can add these as they look. Then the numerators, 3 times negative 24 would be negative 72. Right, 60 plus 12. And then these have the same denominator, 125, so that's going to be the denominator of their sum. And then negative 28 plus negative 72 would be negative 100. And this definitely simplifies. 25 goes into both of these evenly. This is negative 4/5. Negative 0.8, but they said enter it as a fraction. All right. So again, I don't know the measure of A minus B, angle A minus B, but I can tell you that the cosine of this new angle, A minus B, will be negative 4/5. If they gave me all that information about angle A and angle B as they did earlier. All right. So back here, just entering, negative 4/5. Fantastic. Right. Just read through the answer explanations, please. Right. Read through it if you're correct, just to make sure your reasoning was correct, and especially read through the answer explanations if you're wrong. Right? Maybe you can figure out where you went wrong, so the next time you see a problem like that, you'll do better, hopefully. All right, so hopefully watching me do this helps you out when you're working on this kind of problem on your own, and thank you very much for watching.